Hi everyone, welcome to the Earth Science Regents Review podcast series created by Homix Middle School Earth Science Department. Today we're going to be talking about page 12 in the reference table, your relative humidity and dew point charts. Now these charts can be very important for you to be able to identify the amount of moisture in the atmosphere, but there are some key terms that you're going to have to be able to identify. First off, that's going to be your dry bulb. Dry bulb is just very simply going to be the outside temperature. You also have your wet bulb, which is going to measure the evaporation within the atmosphere. Because evaporation is a cooling process, evaporation is going to cause the wet bulb to be a little bit less than the dry bulb. Sometimes they'll be the same, and I'll show you some examples about that a little bit later on. But the wet bulb essentially is going to be less than the dry bulb, which is going to tell us a little bit about the amount of moisture that's in the atmosphere. Once you get those two temperatures, you subtract them. That's either called the difference or the wet bulb depression. So let's just kind of put you right into these, and we'll give you an idea in terms of how to use these two charts. And we're going to start off first off with the dew point chart. The left-hand side of your dew point chart, that's your dry bulb temperature. Along the top here, that's going to be the difference. Those are going to be the two values you're going to use to figure out the dew point and the relative humidity. So let's show you a quick example. You have a dry bulb of 12, wet bulb of 8. You take those two temperatures and you subtract them, you get a difference of 4. You're now going to use the dry bulb and the difference to get your dew point. So let me show you. You find your dry bulb of 12, you find your difference of 4. You bring the dry bulb across, you bring the difference down, where they both intersect, that's going to be your dew point. Now you see here that you have a dry bulb of 12 and a dew point of 4. That's about an 8-degree difference there. Your air in this case can be relatively dry. You're probably going to have some pretty clear skies with that combination of temperature and dew point. Because you know when the closer the dew point is to the dry bulb temperature, the better chance you have for rain. In this case, they're pretty far apart. What happens when you're given the actual difference already? The subtraction's already done for you. So the difference is 10, and they give you the dew point of 6. We want to find the dry bulb and the wet bulb. We want to figure out what were our two initial temperatures that are going to give us a combination of a 6-degree dew point. So let's show you. You come to your chart, you find your difference of 10. You follow 10 down until it hits the dew point value that was given to you, and that was 6. You take 6, you follow it across. That's going to give you a dry bulb of 24. Now, knowing that the wet bulb is always less than the dry bulb, you ask yourself, what number are you going to take away from 24 to give you an answer of 10? And the answer in this case is going to be 14. So you'd have a wet bulb temperature of 14. So you see that you can use these charts a little bit backwards as well. To give you one more example with the dew point. Dry bulb of 2, wet bulb of 2. You subtract them, you get a difference of 0. From there, we want to know what is your dew point. You're going to use 2, you're going to use 0 in order to figure out your dew point temperature. So you find 2 in your dry bulb, 0 as a difference, follow 2 across, follow 0 down, you end up getting a dew point value of 2 degrees. So your air temperature and your dew point are identical. You're probably going to have 100% humidity this day. You're probably going to get some rain at some point in your forecast. So that's it with the dew point temperature. Let's check out your relative humidity. The nice thing about these two charts, they're done identically. So your relative humidity, again, left side is your dry bulb, up top is going to be your difference. Let's give you a couple examples here. Dry bulb temperature outside is 4, wet bulb is -2. That's going to give you a difference of 6. We want to know what is your relative humidity. You're going to use your dry bulb, you're going to use your difference or the depression. So what you're going to do, you're going to find 4 as a dry bulb, 6 as a difference, follow 4 across, follow 6 down, you have a relative humidity of 14%. Well, imagine you have a glass of water that's only filled up 14% of the way. You don't have a lot of moisture in it. There's some very, very dry air. So not a good chance for rain this day, probably had some beautiful weather. Second example, dry bulb of 10, wet bulb of 10. You're going to subtract them, you get a difference of 0. What's your humidity in this case? You're going to use your dry bulb and your difference in order to find your humidity. So you find 10 as a dry bulb, 0 as a difference, follow 10 across, follow 0 down, you have 100% humidity. You have a glass of water that's filled up 100% of the way. You have a great chance for precipitation this day. Chances are you're going to have a lot of cloud formation in this case. You have a lot of clues outside that are going to tell you that you have a lot of humidity in the air. That's the highest humidity is going to be able to get. You have a good chance for precipitation. This combination here would be synonymous with the air temperature and the dew point being very close together as well. Great chance for rain there as well. Last example, going to do a backward problem here. So you have a wet bulb of 8 and a humidity of 47%. We want to know the dry bulb and the wet bulb again. So you come to your chart, you find a difference of 8, you follow it down till you come to the given relative humidity, and that was 47%. You take the 47%, you follow it across to your dry bulb, that's 28. Now you ask yourself, what number are you going to take away from 28 to give you an answer of 8? In this case, your wet bulb temperature is always less than the dry bulb. 28 for the dry bulb, 20 for the wet bulb is going to give you a difference of 8. So that's how you're going to use those two charts. But there's a couple things that you really need to remember. When the dry bulb and wet bulb are really close together and you have a very, very small difference, you're going to say that the air is going to be saturated, which means it's going to be filled up with moisture. Humidity is going to be close to 100%. If the dry bulb and wet bulb are really far apart, you know that the air is very dry. You have a very, very little chance for precipitation here. So the numbers are going to tell you a little clue about what type of moisture you're going to have in the atmosphere. So that's it for these two charts. Good luck with this, and we'll talk to you soon.